2 logs. Okay, so who here is scared of logs? Okay, who likes logs? Okay, one person. All right. Logs are not scary. Are you scared of square roots? Maybe a little? Logs and square roots are very, very similar, except square roots are two numbers that are the same two numbers gives you your answer. Like if I wrote down the square root of 9, you say to yourself, you have it memorized, but you really, what we're doing is, why is this 3? It's 3 because 3 times 3 equals 9. That's why it's 3, right? Since 3 squared is 9. That's why. What about a cube root? Like if we said the cube root of 8, what's the answer to that? 2. Why is it 2? Since 2 cubed is 8. And that cube is saying, what's 3 numbers, the same 3 numbers, multiply to give me 8? Okay? Logs are the same, except you're looking at the powers. So we just looked at the powers, and that's all logs are. So let me write down a log, and you can tell me in the next 2 minutes every log I write down, as long as it works nice, just like a square root. Okay? We know the powers that I told you needed to know for 2, 3, 5, and 10. Okay? You've got them all in your head, or you can look back in your notes at the powers that we know. So this is how a log works. Log base 2. It's just like a square root, log base 2, except we're saying the powers of 2. So when we put the base 2, we're saying, okay, think about all the powers of 2, which are what? 2, 4, 8, 16, 32, 64. That's as high as I want you to know. There are more, of course. But when you see a base 2, that's what you're thinking. Okay? If I put a 16 here, so what you're saying, sort of like these up here, is what power of 2 is 16? Which, this is the power 1, power 2, power 3, power 4. 2 to the 4 equals 16. So the answer here is 4. That's it. That's what a log is. It's saying, what is the power? That's it. Are they scary? Only because they teach you using this inverse relationship. Every time you see a log, you write this. That's not what we're going to do here. Okay? We don't write an inverse relationship every time we solve a cube root. We just do it. I don't say, okay, well, you see a cube root here, so write 2 to the power 3 equals 8. I don't get you to do that. No one has ever gotten you to do that. So when you are asked to do that same little inverse relationship, you might not even know what I'm talking about, and that's good, because I want you to get that out of your head. That isn't not a good way to solve logs. So some logs work and some don't. If I put down log base 2 of 10, is 10 a base of 2? No, here's the 2. It doesn't land here, right? It's not a power of 2. Could you guess what it's equal to? What's it between? It's between 8 and 16? Closer to which one? Closer to 8. So let's guess that it's equal to 3 point... Change those word guess, little squiggly equals, to say it's not quite. So if it doesn't work out, just like a square root, you can guess by looking at what it's in between. The problem is that you don't know the powers of 2 very well. So you might have to write them out when you see it. And that's what I said. I told you how high I want you to know. I'm not going to ask any question higher than that. So let's say I put log base 3 of 27. So what's the question? We're talking about powers of 3. Is 27 a power of 3? Yeah, it is. 3, 9. 9 times 3 is 27. 27 times 3, 81. Those are the most I want you to know. 27 is 3 cubed. So what's the answer? 3. It's just the exponent is the answer. That's all it is. Now, what I usually do when I solve them is one step different. So I would say, okay, if I had log base 3 of 81, I say, okay, what's 81? 81 is 3 to the 4. So I just Now, there's a rule of logs that say when these are matching, the log and the base of the log and the base of the exponent, they sort of cancel and your answer's 4. Or you can just say what power of 81 is. Okay. We do this in square roots, sort of. If you have, or cube root. Say we have a cube root of x cubed. What's that equal? X. They cancel. Because they're the inverse of each other, they cancel out. So this is just equal to x. That's the same, the rule for logs is this. If we have a base matching this base, then they cancel and the answer is x. And the other way around, if we put a to the power log base a, that answer is also x. And that would be like doing this, the cube root of x cubed. All right, don't get confused, because I've not introduced anything weird. I'm just showing you how they cancel each other out. Okay. So we're going to back up a bit, and there's something called the inverse relationship that I don't like to use, so I'm going to write it down so that you can remember what it is. So if we have y equals log base a of x, then they're saying anytime you see that, you can rewrite it to be a to the y equals x, and then you're solving an exponential instead of a log. So you can use that, but I'm going to show you an easier way than trying to remember that. Okay, so basically that's what we're going to do next class. I'm going to show you an easier way than every time you see a log to rewrite it. Okay, so what we need to know, though, before I continue this section, are your powers of 2, 3, 5, and 10. So just think about those, 2, 3, 5, and 10. They're the powers we're going to look at. We could do, like, 7, but it would be like 7 squared is 49. I wouldn't expect you to know 7 cubed, right, without a calculator.